Hello, October 12th, 2020, Rock Tavern, New York, at Post Trail Handling. My name is Pat Heater, and I'm giving a demonstration of our post lift. It's a platform post lift, and the design requirement for this is to lift approximately 2,000 pounds to certain elevations, to either floor level, a stair level for removal of materials, or a 52-inch, it's not a real tall lift, 52-inch level to get into the process area. So we have a ramp on here. You can easily roll materials up. It's a 3.6 degree slant on the ramp, so easy to push. The ramp lifts up into position, and to avoid any back strain, you don't actually have to lift it when it's down there. It'll raise up to a certain height before you lift the ramp. And it's got safety gates at the stair level and at the floor level, where you can open these guys up and get your materials in. This is a 72-inch platform, 72 by 72, so it's very large, it's very strong. The whole thing, the underside, is very structurally stable, and so right now we cannot raise with the gate up, you can't reset, and it indicates the front gate is open. So I'm going to close the gate. And reset. Okay, so at this point we can raise the platform. And it will automatically come up and stop at the 16-inch height. That's at our stair level. And release the button, push the button again, and then we're going to go up to the ergonomic ramp lifting height, which is right here. Okay, and now, not even bending my back at all, I can raise the ramp, and now I can continue. I couldn't continue past this elevation without the ramp raised. So now we raise up to our secondary height. And this can be at any height. This lift isn't very tall. We can go 20, 25 feet, whatever, mezzanine height, which is a more common application. But this one, the requirement was just 52 inches. So it goes up, stops at 52 inches. And I'll just bring it up a little bit more. I'll lower it. And in reverse, it's going to stop at that ramp height again. There's ramp height. Lower the platform. And then we continue downward. There's the second step height. Notice the motion profiles. It goes through an accel, a decel, not just a accel and decel in the drive, but it follows a trapezoidal motion profile, same algorithm that's used in multi-axis robots. This technically, the way it follows the motion profile, it's a single-axis robot, just a platform, but it is following the algorithms. So let's get a look at the HMI here. We have a touchscreen operator interface where you can do operations on it. It's easy to press these buttons, you know, if you're wearing gloves. But there are a few nice things on here. There's a positioning screen for setup where you can jog the machine up and down, and it overrides, you know, some of the settings. There's a configuration screen. Here you will you'll set the heights for the different levels. This is the lower loading position, and you can, wherever you are, you just press and hold this button for 5 seconds. I'm not going to do it, but wherever you are, it kind of teaches that position. So next position is the stairway landing, so you would lift it up with manual controls, press this button for 5 seconds, and it stops at the stairway. And then we have the ramp raise position, that ergonomic, don't hurt your back position next, and then the highest position. over there. And there's a button to override lift errors, like if like the chain tension procs, if it comes down and hits on something, it's going to stop, or it comes up against something, it will stop. And once maintenance gets on it, removes whatever the obstruction is, you can override the lift to get out of that position. Okay, configuration screen, or diagnostic screen. This tells you all the inputs and outputs on the machine, and any errors. You don't even have to open the box and look at the PLC. You don't need a computer to diagnose this. Everything that you want to know is right on this screen for diagnostics. The encoder bits on, off, the home switch, the over travel proximity sensors, the status of the safety gates, open, close, emergency stop button, reset push button. Push it, it turns into a 1 there, and the reset button, let go of it, goes to 0. So the raise and lower buttons, and all the outputs. The motion control is all done through Ethernet communications with a PLC, Ethernet IP to a frequency drive, and that's how we get such precise and really good positioning accuracy and that ramping of the speed. The algorithms are all done on the PLC, not just the simple ramp of a frequency drive. We wrote the ramping algorithms ourselves. So that's it. That's everything.